Okay, so what we've done so far, yesterday, well, we did greatest common factor on Monday. We did normal factoring on Monday. I say normal. And then yesterday we did the factor by grouping for 2 of these examples. And this is where your A is not 1. So we have like a coefficient in front of the x squared. And you have to multiply those 2 and then list the factors. And then I showed you this slide and divide, and really it should be divide and slide, but whatever. I want to show you one more way to do this. And then this idea that it only works if there's no greatest common factor if you divide it out first. That actually doesn't matter when you're just finding solutions. And I didn't think that through yesterday when I showed you. Because I'm not used to our old book didn't have us always just solve for 0. They also had us just factor and stop there. But since this book is always having us actually solve, go all the way, the divide and slide is actually like a really good method. So if you can flip all the way to the back side, this blank side here, I want to go through 2 examples that are actually from your homework. Specifically, I think they're number 4 and 5. So factor by grouping is still the mathematically sound, good way to do it. If you're asked on the SAT to factor something and not solve, it is the way that every time it will work. So it's good to know, but this slide and divide is actually really nice too when you're solving. So I'm just going to title this factoring and solving when A is not 1. Okay, so I'm going to call this divide and slide like we did yesterday, although I think I said slide and divide. And then I'm going to do something weird. I'm actually going to cross off that, like, so still write slide, but cross it off because actually with the solution, we don't technically have to do the slide part. And I'm going to show you what I mean here in a second. So I'm going to do 2 examples, and these are from your homework. So if you didn't finish your homework, you can go back and look for these. Let's call this A, and I think this was number 4. And the problem was 6x squared minus 5x minus 4 equals 0. And the fact that it's equal to 0 means you should check for greatest common factor if you can and divide it out. But if there is one, you can divide both sides, and anything 0 divided by anything is 0. So that greatest common factor ends up not being an issue. So I'm going to say in my steps, like step 1, factor out GCF if there is one. But mostly that's just to make it easier for you so you're not working with bigger numbers. And I guess if you don't catch that there's a GCF, it wouldn't actually matter for these. You would have an incorrect like factored form, but your solutions will still be the same, so it doesn't matter. And that's what I did not anticipate yesterday when I was going over this. So your second step then is still to multiply that first and last term. So multiply A and C, like I showed you yesterday. So what's 6 times negative 4? Negative 24. And then I'm adding to a negative number here. So I want to find factors of negative 24 that add to negative 5. If it adds to a negative number, the bigger part needs to be negative. So it would be 1 and negative 24. That adds to negative 23. That doesn't work. 2 and negative 12. We're getting closer. That adds to negative 10. How about 3 and negative 8? That one work? Okay. So you're going to list your factors, and then once you find it, you have these factors. So I guess step 3 was list factors. List factors and find the 2 that add to B. So list factors and find the 2 that add to B. So we've done that here. And here's where I'm going to do the slide and divide a little bit different than I did it yesterday. So for our step 4, I'll say write factors and divide by our a term. So divide by a. So what I mean by that is when I say write factors, those are our parentheses that are being multiplied to equal 0. And yesterday, the way I wrote them, and this is still technically correct too, is that I wrote this number 6x. Today, let's just do it this way. You're going to write x plus 3 from that factor and x minus 8. But then the divide part, I want you to put this divided by this number here. Okay, so divided by 6, divided by 6. That's actually the divide part of divide and slide. So here, is 3 actually divisible by 6? No, but what can we do with 3 over 6? We can reduce it. And actually, same thing with 8 over 6. So once you have that division, you're going to simplify / reduce if possible. And in this case, it is. So it'd be x plus 1/2. And this would be x minus, these are both reducible by 2, right? 8 divided by 2 is 4. 6 divided by 2 is 3, equals 0. Okay, so what normally would happen here is that if I was just asking you to factor, the slide part of divide and slide is where you take this bottom number, and if you still have a fraction, you slide it over to this front coefficient. So I'm going to put a little star here. Factored, this would be, it would be 2x plus 1 and 3x minus 4 equals 0. Whoops, you guys can't see that. That would be the official slide part. Now here's where our book comes in handy though. If we're solving for 0, typically if I was asking you just to factor something, we do not want fractions in our factors. Okay, so I don't know the reason for that. It doesn't look nice. I don't know. The math gods say don't do it. But since we're solving, remember our zero product property still says either this parenthesis is 0 or this parenthesis is 0. And do you guys already see the solutions? If I were to set these equal to 0 with the fractions, what would my solution be? And positive 4/3, right? Yeah, I mean, so what's the point of me sliding over, setting them equal to 0, and then undoing that anyways? Does that kind of make sense? So I guess I just didn't even realize this yesterday when I was showing you this. The fact that we're just solving for 0, just jump right down to setting these equal to 0, because a lot of times we can just see then what the answer is. So we'd have x minus 4/3 equals 0, x plus 1/2 equals 0. So we'd end up with x equals negative 1/2 and x equals positive 4/3. Versus taking this and setting these equal to 0, we'd still end up with the same answers. But the fact that I didn't ask you to factor this really, I mean, I asked you to factor it in as far as like solving it. This is plenty. So the divide and slide is kind of a nice method for these. So this was number 4. It was negative 1/2 and 4/3. Let's do one more, just so we have more practice, and I won't annotate this next one as much. So you have all your steps here written out, and it's a nice, easy method, but let's look at it a little quicker without me writing out every step. So example B, I believe this was number 5, was 5x squared plus 28x minus 12 equals 0. So I think this was number 5 from your homework. All right, so what's my first step? 5 and the negative 12. So I get what? Negative 60. Good. I need to add to a positive number, but multiply to a negative. So in this case, my smaller number will be negative. Negative 1 and 60, that would be 59. Negative 2 and 30, there it is. Usually you can find it pretty quick. Negative 2 plus 30 is 28. So what we're doing different than what I showed you yesterday is now you're going to take those factors and you're just going to write x minus 2, x plus 30 equals 0. But then take both of these parts and throw them over your a term. So divided by, what am I dividing by? 5. All right, 2/5. Can I reduce that at all? No. If I was just asking you to factor this, you would slide it to the front. I'm not asking you to factor this, so let's leave it as a nasty little fraction because it'll make it easier. What about 30 over 5? What is that? 6. That's nice. So this is factored, and I'm putting that in air quotes because I guess officially it's not factored according to someone. But we're good to now do our zero product property. And really, hopefully you guys are quick enough to see if you set this equal to 0, you just change the sign, right? So I'm going to have x equals positive 2/5 and x equals negative 6. Isn't that nice? That's a big reason why, yeah, I guess I didn't think divide and slide. If I'm not asking you to factor and I'm just asking you to solve, that's totally the way to go. Does that make it a little more straightforward? Because factor by grouping, I know a lot of you gave that the good old college try. Thanks. I like it. It's a good way to go, especially when you're asked to factor. But since we're asked to solve here, there is no reason not to use this divide and slide. Okay, I have some more examples to do, and then we will turn to our homework, which should be pretty quick today. So if you could please flip to our second to last page. We are going to learn about 2 special products. So these are special forms of quadratics that if you can memorize this, it makes life easier. Technically, I don't have to show you either of these because you can still just factor the way we've been factoring, but there is some convenience to knowing what these are. So there's 2 different ones. This didn't photocopy great, but the first one's a difference of squares. So difference of squares is where you're going to have like a term that's squared minus another term that's squared. So for example, you could have something like, I don't know, x squared minus, what's a perfect square? 9 equals 0. The rule is that these will always, so if you have this is squared minus this is squared, if you were to take the square root of both of those, it will always, always, always factor as x plus 3, the square root of 9, and x minus 3, the square root of 9. You'll just have a plus and a minus. The order doesn't matter. If you do a minus and a plus, that's fine too. But this is called the difference of squares. And if you can spot this, it makes it very easy to factor. You don't have to go through, because normally we would say, okay, x squared minus 9 is the same as x squared plus 0x minus 9. And you guys would list factors that multiply to negative 9 and add to 0. And do you see how negative 3 and 3 does that? This is just saying skip all that, recognize what this is, and factor it. So difference of squares is the first one. The next one I stress less. We will use it when we complete the square. But this is called a perfect square trinomial. This one, if you can spot it, great. If you can't, I'm not worried about it. So its kind of rules are that you have a squared term plus 2 times your AB plus B squared equals a squared factor, meaning 2 factors that are exactly the same. So let's work backwards. Say I was assigning you a perfect square trinomial. A perfect square trinomial could be something like x plus 7 squared. If I were to expand that, that would be x plus 7 times x plus 7. That's what it means to be a square. So you have 2 things being multiplied. If I were to FOIL that out, that would look like x squared plus 7x plus 7x plus 49. And if I were then to combine my like terms in the middle, it'd be x squared plus 14x plus 49. This is a perfect square trinomial. And if you happen to be able to recognize that, hey, 49 is a perfect square, I know the square root of 49 is 7, and 7 plus 7 is 14. then you would know that you could jump right to factoring x plus 7 squared. Now, is it necessary? No, because you could still just list what two factors multiply to 49 and add to 14, and you'd still end up with this x plus 7 times x plus 7. The reason I do want to show it to you still is I want you guys to be comfortable with this idea that x plus 7 times x plus 7 is the same as x plus 7 squared. I think there were a couple Blockt problems yesterday that looked like that. Again, if you don't recognize those, not the end of the world. So I'm not going to do all these examples. In fact, I think I'm going to do example 4a and b and 5a and b. So example 4, these are just factoring a difference of squares. As another quick reminder, difference means subtraction, right? So in the middle, you're going to have a subtraction sign. Because if you look at part A here, we have a plus here instead of a subtraction. So this is not a difference of squares. So example 4 is the more typical one. You can list, so is 81 a perfect square? Yes. Sure is. It's a perfect square of what? Two numbers. 9, right? So it's 9 and 9. Except to multiply to negative 81 and add to 0, it'd have to be a negative 9 and a positive 9. So this just factors as x plus 9 times x minus 9 equals 0. And it's like the quickest factor ever. And then if we set each of these equal to 0, you would have x equals negative 9 and x equals positive 9. So on Go Formative, you can either list negative 9, comma 9, or if you guys want to use the plus or minus 9, I have all of those answers in today. So you are welcome to use the plus or minus, or you can just list them. I have it in both ways. It's easy, right? All right, how about 25? What is this a perfect square of? 5. So it'd be negative 5 and 5 if you even want to list that, but you could just jump right to x plus 5, x minus 5, or x minus 5, x plus 5, doesn't matter. If you set these equal to 0, you'd have x equals negative 5 and x equals positive 5. So on Go Formative, you could just put plus or minus 5. I'll skip part C just because I want to give you guys time to work on your homework, and I still want to get through example 5. But part C, you would just add the 10 over, and then you'd have a perfect square, because 59 is not a perfect square. Questions about difference of squares. Those are handy to know, because if you think about like seeing those on your SAT, if you were running out of time and you saw that, that should be like a real quick factor. This one's a little weird for me. And I guess I'll explain why for part B here, but this wants us to solve a complex solution by factoring. I've never done this by factoring before. In general, I would just set it up like this, and then I'd take a square root of both sides. And taking a square root of a negative 144, I'd know I'd have an I. But your book does this, so we're going to do it. It's fine, and it probably won't be on your quiz. So let's notice here, this is not a difference of squares. There's a plus here. So if we want to make this look like a difference of squares, what we need to do is we need to write this as x squared minus negative 64 equals 0. Okay, if it didn't have the negative here, 64 is what squared? Yeah, it's 8 squared. So this is the same as x squared minus negative 8 squared. But how do I get this negative here? Because it was a plus. Well, let's recall, and I've erased them now, but I squared is equal to what? I squared is equal to negative 1, right? So if instead of writing it this way, if I wrote x squared minus 8i all squared, that's a difference of squares. So this is kind of convoluted, but basically then I'd have x minus 8i times x plus 8i equals 0. And so if I set each of these equal to 0, I'd have x equals plus or minus 8i. There's going to be some on your homework that look like this. I don't think I'll put this on the quiz. It'll be on the quiz in other ways, but not like factoring it because I don't like to factor it. That's a weird way to do it. We'll go through part B real quick as well, just to practice this. So it's not set equal to 0 right now. So I need to set it equal to 0 by adding 144 to both sides. So I'd have x squared plus 144 equals 0. So what I really want you guys to focus on, the difference between example 4 and 5 here, is that we have a plus in the middle or we have a minus. If you have the minus, you can just take the square root of this number and know you have a positive and negative. If you have a plus here, what is the square root of 144? 12. But if I have a plus here, I'm going to add an I. So this will factor as x plus 12i, x minus, whoops, I almost put 8i, x minus 12i equals 0. Set that, so this is factored. Set each of these equal to 0 using the product property, and I would have x equals plus or minus 12i. So truly, the only thing I want you to take away from this is the sum of squares. You're going to have an I part. The difference, you'll just have like the normal number. Okay? Weird concept. It's weird to factor it to me, but whatever. Your book wants to do it, so I'll give it to them.